Look at that number. How many of you want to write that number down 10 times? None of us. We don't want to do that. We don't have to keep track of all those zeros, and it's going to take a long time to write. There's a much more convenient way to write this number that we're going to learn about, and that's called scientific notation. Scientific notation is used to write very large or very small numbers, and we do it because nobody wants to write a number like that. It's just a shorthand way of writing large or small numbers. So the way this is done, what you try to do, you look at the number that you have, whether it be large or small, and you say, how do I take those digits and write them in a way so that the number is somewhere between between 1 and 10? Well, this number I can write it as 6, right? I can move a decimal somewhere, like the decimal of the number's here. I can move this decimal wherever I want to, but I'm going to move it somewhere so that number is somewhere between 0 and 10. Well, I'm going to stick it right there, right? If I put the number there at 60, if I put the decimal there at 602, if I put the number there at 6020, but if I put the decimal there, the number becomes 6.02, and I can drop all those zeros. So I'm going to do that. I'm going to write this number as 6.02. Now, of course, these numbers aren't equal, and we've got to keep them equal. Okay? I can't just go doing this. I've got to keep the number the same. So I need to think about what I actually did to convert this number to this number. What did I do? Well, what I ended up having to do, let's see, I took this number, this decimal, and I moved it a whole bunch of times. Let me count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Woo! So, basically, that's 23 times. I'm going to write that down. 23 times I moved the decimal. And every time I moved the decimal, when I moved it here, I divided, that's basically the same as dividing by 10. And if I move it again, I divide it by 10 again. So I divided by 10 to go from here to here, a total of 23 times. So 6.02 is this number divided by 10 23 times. So how did I get that number back? Well, I have to multiply by 10 23 times. So that's what I do. Well, I don't want to keep writing times 10 times 10 times 10. That defeats the purpose. So what we do is we multiply by 10 a total of 23 times. That's it. That's how you write numbers in scientific notation. Now in this case, I took a number that was very large and wrote it like this. There are cases where we're going to have numbers that are really small. And in that case, we're going to have to do the opposite. So let's see what's going to go on in that particular case. So let's write this number here. All right, that number, I want to write this in scientific notation. So once again, the first step, I'm going to move my decimal some way so that the number becomes a number between 1 and 10. If I put it there, it's going to be 0.529. If I put it here, it'd be 529. If I put it here, it'd be 52.9. Aha! If I stick it right there, that's the sweet spot. 5.29, that's a number between 1 and 10. So I'm going to write this as 5.29. Well, how did I get there? How did I change this to 5.29? I moved the decimal how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. And in this case, each time I moved the decimal this way, I multiplied by 10. Multiply by 10, multiply by 10. So in this case, this number is this number multiplied by 10 12 times. Well, to get back to where we want to be, we're going to have to do the opposite. We've got to divide by 10 12 times. Like that. Well, that's not how we do this here. We're gonna use this trick. Remember that this is actually 10 to the minus 12. Remember that? Like if we go 1 over a, that's the same thing as a to the minus 1. 1 over a squared is a to the minus 2. In this case, this number over 10 to the 12th, that's the same as multiplying by 10 to the negative 12. So because I divided by 12 10 times, I'm going to write this as times 10 to the negative 12. If this isn't making a whole lot of sense with this kind of thing, just remember, if you end up having a large number, you're going to move the decimal so the number ends up being somewhere between 1 and 10. You're going to count how many times you move the decimal, and you'll write that number times 10 to the positive number of times that you moved the decimal if the number that you started with was big. If the number that you started with was small, such as in this case, once again, you move the decimal so the number out front is somewhere between 1 and 10. You count how many times you moved the decimal. In this case, it was 12. And then you take that number and you multiply it by 10 to the power of 12. But if the number is small, you put a little negative sign out there in front. This and this are identical numbers. That's it. Do some problems. Let's do some problems. I think on slide 11 there are 2 examples for you to try. Some simpler examples. I want you to try to write the number 15,000 in scientific notation. And I want you to try to write the number 0.00912 in scientific notation. All right, now that you had a chance to try that, we're going to demonstrate how to do it. This number here, if I want to write it as a number between 1 and 10, I think you'll agree that that's going to be 1.5. The decimal started here. I had to move 1, 2, 3, 4 spaces in this direction in order to be able to write this as 1.5. So I'm going to write this times 10 to the power of 4. And because the number was large, we're going to keep this positive. In this particular case over here, I'm going to move my decimal here to write this as a number between 1 and 10. Notice I had to move the decimal 1, 2, 3 times. And because it's a small number, we're going to go ahead and make this a negative 3. So this is how we'd write this number in scientific notation, and this is how we'd write 15,000 in scientific notation.